Hi students, welcome to Alphos e-learning program mathematics class. Earlier section we have discussed about equation of oblique parabola under different conditions. Now let us do some problems. Before that, let's have a glance on the another kind of oblique parabola also, and that is nothing but when focus given and directrix equation given. Of course, all of you know very well, when focus is given, directrix equation is given, we know the equation of parabola is simply from the formula SP equal to PM. That means whenever you have observed any equation of this model, that is under root of x minus alpha whole square plus y minus beta whole square is equal to some Lx plus My plus n, okay, divided by under root of L square plus M square. So if at all we observe any time this kind of equation, clearly we can understand this is representing equation of parabola whose focus is nothing but how much here? Alpha comma beta, and directrix equation is nothing but how much here? It is Lx plus My plus n equal to 0. So this is directrix equation and these are our focus coordinates. Using these actually we can say this is another standard form of oblique parabola, right? And now basing on this actually one important concept is there, and that important concept is nothing but here, suppose we have taken a fixed point, that is some alpha comma beta, this point is fixed, and one line also here fixed, this line is here fixed line, suppose Lx plus My plus n equal to 0. So this is a fixed point given in the data and a fixed line is given like this. So this is given in the data, and now they will ask about what about locus of centers of all circles, right? Locus of centers of all circles. So one of the important concepts, students, here, locus of centers of all circles. And what is the nature of these circles actually? These circles, they are passing through this point and at the same time they must touch the fixed line, okay? How are these circles actually? Which pass through, okay? These circles are all passing through the fixed point here, alpha comma beta, and touches the fixed line, and that one is nothing but Lx plus My plus n equal to 0. What is that? Locus of centers of all circles such that they are passing through. So what about that kind of equation of circle? Understand here, locus of centers of all circles, and how are those circles? They are all passing through the fixed point alpha beta and touches the fixed line Lx plus My plus n is 0. So this is fixed point and this one is here fixed line. What about locus of all centers? Suppose if I am taking here, this is the circle. Understand? So one of the circles I am taking. So this is our circle. One of the circles we are taking. It is passing through alpha beta and touches this line. The requirement is here locus of centers. What about here other one? Suppose this is one of the center of this circle. So for this circle the center I am taking x1 comma y1. Again another circle you take, suppose this is another circle, again it has to touch, actually that also has to touch this line, at the same time it is passing through the point. Then this circle center, suppose you consider x2 comma y2, like that here again another point, we have another circle you are taking which is touching the circle, like this here. If you consider circles, they are asking about what about the path of all these centers. For that purpose, let us consider here one of those circles, and let me take here the center is nothing but suppose x1 comma y1. Now you know here this is tangent to the circle and this one is a point on the circle. Therefore, if this is the center of the circle and this is any point, suppose you take it is P and this one is here line L, then we know clearly CP is nothing but what here? Radius of the circle. At the same time, perpendicular distance from center onto the line is also here radius. Therefore, we can say CP equal to nothing but how much here? Perpendicular distance from center onto the line. That implies what is our complete here conclusion. Now, it is nothing but x1 minus alpha whole square plus y1 minus beta whole square is equal to, what about this side here? Perpendicular distance from center onto the line, that is nothing but mod of Lx1 plus my1 plus n divided by root of L square plus m square. And this is true for any center, whatever circle you consider, for all of them, whichever are satisfying the condition, that circle is passing through the point and touching the fixed line, you can obtain this one. Now students, what about here? This condition exactly, it is representing nothing but SP equal to PM. Okay, for x1 y1 we take, again for x2 y2, again for x3 y3, etc. Therefore it is nothing but again a parabola. Therefore, what is the answer here? Locus of centers of all circles which are passing through a fixed point and touching a fixed line is nothing but a parabola, where the fixed point is nothing but here what? Focus of the parabola, and the fixed line is nothing but here directrix of that parabola. Okay, so one of the important concepts, oblique form. In this way also they may ask here about the question. Okay, so what is the locus, students? The locus is nothing but here parabola, and what about here the fixed point? This point is nothing but focus of the parabola, and the fixed line is nothing but here directrix of this parabola. Okay, then the question they ask indirectly. How they can ask the question? Find equation of, they ask the question like this: find equation of locus of, okay, find equation of locus of centers of circles, equation of locus of centers of circles. And how are all these centers? Centers of circles which are all passing through fixed point, okay, which are all passing through a fixed point, some -1, 0, and touches, the circles are touching here, touches a fixed line. That fixed line they may give here some value like x minus 3y plus 4 equal to 0. So if a problem is given in this way, then what is simply you can write here, this is your focus and this one is your directrix, and the circle and the locus equation is nothing but here SP equal to PM. That implies it is nothing but under root of x plus 1 whole square plus y square equal to, this is mod of x minus 3y plus 4 divided by root of how much? 10. That's it. Simply you can write equation of parabola whose equation is SP equal to PM. That's it. Understand, students? So directly they may not ask what is equation of parabola, but they may ask here locus of centers of all circles which are passing through here a fixed point. So here we write which pass through fixed point, and the next one is here which touches a fixed line like x minus 3y, some line they'll give. So in this way we can obtain directly parabola equation, right? Now let's have a glance here on these problems. Observe here the first problem. What did they ask here? The data given as focus coordinates 3, 5 and vertex given as 1, 3. Okay. Earlier also we have done this problem when axis is a long coordinate axis, either x-axis or y-axis or horizontal or vertical, like that we have done this model. Now in this way here abscissa and ordinate relation, if you observe in both the points, here abscissa not equal or ordinate not equal. Earlier we did when abscissa is same or ordinate is same, but now it is given those are unequal. That means this parabola is an oblique parabola. How to find then? So equation of parabola we require. To obtain parabola, what are our requirements? If you know focus, then the other requirement is directrix. Or else if you know about axis equation, understand, tangent at vertex also we require, and along with this you need to find latus rectum also. Therefore, what are our requirements to obtain a parabola equation? Either focused directrix combination you require, or else axis equation, tangent at vertex equation, and length of latus rectum. So if you are having these data in your hand, then easily you can obtain here equation of parabola. Now here students, you have one of the values focus already there. Then let us find here equation of directrix. Even these also you can find, but here all the three values are new values you have to find. Whereas here already one value exists, therefore only one is sufficient, that is just directrix equation. So I am selecting here this method by choosing focus and directrix because already focus is given, right? And now how to find here directrix equation? Then let us observe here the standard form. That means here if this is the parabola and now the focus is given already how much here 3, 5 and vertex is given how much here it is 1, 3, then this is our directrix, right? And directrix students, you know very clearly that if this point is suppose Z, that is the foot of perpendicular drawn from focus onto directrix, if this point is Z, then you know from the standard form SA equal to how much here AZ, right? SA equal to AZ implies A is middle point of S and Z. So all of you know if this is XY and this is X1 Y1, then what about Z coordinates? It is 2x minus x1 comma 2y minus y1. So Z coordinates, those are nothing but here x2 y2, it is equal to 2x minus x1 comma 2y minus y1, and in this way if you find this is 2 minus 3, that is how much here it is minus 1, and next value 6 minus 5, that is 1. Therefore clearly you got Z coordinates, that is nothing but minus 1 comma 1. Okay, now once you got Z value students, what about the next thing here? Equation of directrix, right? Now what is the relation between directrix and axis here? These are mutually perpendicular, right? And now what about here? Slope of AS. Slope of AS y2 minus y1 by x2 minus x1. Therefore this slope is nothing but 5 minus 3 by 3 minus 1. Implies the slope here it is how much? 1. Therefore directrix slope is how much here? Minus 1. Those are perpendicular. Hence now you can find equation of directrix. So what is the directrix here? It is passing through Z. So y minus 1 having slope minus 1 and into it is x plus 1. Okay. And now if I take this value minus 1 get cancelled, the equation is x plus y equal to 0. Understand students? Therefore this is our directrix equation and focus already there. Hence what about here? Equation of parabola, that is SP equal to PM formula we apply. Therefore P is any point here on the locus, then SP equal to PM. If you make use of this formula here, where P is here x comma y, then this is nothing but under root of x minus 3 whole square plus y minus 5 whole square and equal to mod of it is x plus y divided by root 2. Perpendicular distance in general we take from a point x1 y1. Here directly we are taking x comma y. So if you do simplification, this is 2 into x square plus y square minus 6x minus 10y and 9 plus 25, that is 34, and equal to this side x square plus y square plus 2xy, right? Now take all the terms on one side, thereby 2x square minus x square, it is x square, and minus 2xy and plus 2y square minus y square plus y square. Observe here the homogeneous part you must get as a perfect square. Okay, always that is a very important thing while taking here parabola equation. When it is oblique case, the homogeneous part must be always a perfect square. Then other values you can write, that is minus 12x minus 20y and this is plus 68 is equal to 0. So this is equation of parabola in oblique form. So in this way, whenever focus vertex given, this is the method. First one you have to find directrix. To find directrix, we found here z coordinates using the middle point concept, this one. And once you know about z, these 2 points, they lie on axis, therefore slope of directrix can be obtained. So this is the method, students, when focus and vertex given, where axes are not equal or ordinates are not equal. Okay, now let us observe here the second problem. What is the second problem given? Find vertex of parabola. Okay, focus is given, directrix is given, and they are asking about what is the focus. Okay, focus given and directrix given. The question is, what about here? Vertex of parabola. Okay, so how to obtain this one? Observe here, this is our parabola suppose, and this is our directrix equation. It is given by x plus y plus 3 equal to 0. And here focus is given. What is the focus given here? 1 minus 1. And now the question is what here? What is vertex of parabola? That means this value is how much? Okay. So to find here vertex of parabola, simply just now we have observed, whenever you take foot of perpendicular from focus onto the directrix, okay, this point is nothing but what here? Z. Foot of perpendicular from focus onto the directrix. Suppose if I am taking h and k, then again just like our previous formula, this is our middle point. So all of you know very well about the foot of perpendicular formula. So I am applying here that formula. So first of all we are finding here z, and what is z here? It is nothing but foot of perpendicular from where here? From focus. Okay, s of 1 comma minus 1 on to which one here? Directrix. And that directrix is here x plus y plus 3 equal to 0. Okay, so this is our given value. And now we are finding here z coordinates. So let this be here hk, the formula h minus 1 divided by 1 is k plus 1 divided by 1 is minus of 1 minus 1 and plus 3 divided by this is 1 square plus 1 square. So you will get here 2. Now what about other values? These two values here get cancelled. Therefore h minus 1 is here minus 3 by 2 and k plus 1 is again minus 3 by 2. Hence what about h value here? 1 minus 3 by 2. So 1 minus 3 by 2 means it is minus 1 by 2. And k value, what about this value? Minus 5 by 2. Hence we got z coordinates. What are z coordinates? These are minus 1 by 2 comma minus 5 by 2, right? Once you know about these z coordinates, the vertex is nothing but exactly middle point of s and z. Okay, so what is the middle point formula now here? So here a is nothing but midpoint of which one here? S comma z. So s value 1 minus 1 and z value here it is minus half comma minus 5 by 2. So now let us find here middle point, that is 1 minus 1 by 2 by 2. Therefore it is, what about that value? 1 divided by 4. Okay, and next value minus 1 minus 5 by 2 by 2, that is minus 7 divided by 4. Therefore this is our vertex. So whenever they asked here find vertex of parabola, when focus given, directrix given, first we found here the foot of perpendicular, and once you know about foot of perpendicular, then the middle point of s and z is nothing but our vertex, and thereby you can find directly midpoint concept. Okay, and next one, observe focus given, directrix given. Okay, focus given, directrix given. The question is find equation of tangent at vertex. So how to obtain under this data? Focus is given, students, and next directrix is given. Then how to find here equation of tangent at vertex? Everything just if you draw diagram roughly, you can get direct idea. Okay, so just draw the diagram. Focus given as here how much? 1 comma 2, and next directrix given, this is 2x minus 3y plus 1 is 0. Directrix equation given. and now they are asking about here what is equation of tangent at vertex. So this equation they are asking. Okay, now one of the methods is nothing but, so many methods are there, you can choose any method. One of the methods just now, however, we found from focus onto the directrix you can find foot of perpendicular, and after that you know middle point here, thereby you can find the equation of tangent at vertex. But the easiest one is, students, already you know directrix, and we know directrix tangent at vertex. This is here tangent at vertex, and next this line is nothing but what here? It is latus rectum. We know here these three lines always they are parallel. Moreover, this line is exactly lying midway between these two. Therefore, here it is easy to find latus rectum equation. What is latus rectum equation? Both are having same slope because those are here parallel. Now here slope is how much here? 2 by 3. So you know very well about this formula. Ax plus by plus c equal to 0 is the line. So a line parallel to Ax plus by plus c is 0, and passing through x1 comma y1 is a into x minus x1 plus b into y minus y1 is 0. Okay. So if you use this formula here, what is equation of latus rectum? So this equation is nothing but 2 into, right? 2 into x minus 1, and after that minus 3 into y minus 2 equal to 0. That implies latus rectum equation is nothing but it is 2x minus 3y, and what about constant? Minus 2, and this is plus 6. 6 minus 2 means 4. So this is plus 4 is 0. Okay. So you got latus rectum, and you know already this is directrix given. Then what about here tangent at vertex? It is nothing but a line parallel to these two and lying exactly midway between them. Then what is that formula here? Ax plus by plus c1 plus c2 divided by 2 equal to 0. Now students, you can understand the whatever the concepts we have studied in first year straight line, how much they are useful here. Okay. So now this is the equation of here tangent at vertex, right? So equation of tangent at vertex is nothing but simply we can obtain like this. Now that is 2x and minus 3y, and what are here c1 and c2? This is your c1 and this is your c2. Okay. So these are our c1 and c2. So c1 plus c2 by 2 means it is 5 divided by 2 is 0. That implies 4x minus 6y plus 5 equal to 0. So this is equation of here tangent at vertex. So observe here whatever problem we are doing, just if you are able to remember about the standard form, okay, standard form diagram, where is tangent at vertex, where is focus, where is here directrix, etc. Then whatever data given, immediately you can make use of the leftover values. Okay. Now here focus is given, directrix is given. So we found here equation of latus rectum because of the nature directrix is parallel to latus rectum. Once you got latus rectum directrix, then easily you can obtain here tangent at vertex, which is a parallel line to both of these and lying exactly midway between them. This is the formula for it. Okay. So now we got, students, this equation, that is focus given, directrix given, we obtained here tangent at vertex. Now observe the fourth problem. What is the data given here? To a parabola, directrix is given, latus rectum also given. Then they are asking about here, what about length of latus rectum? Okay, length they are asking. So what is the data, students, given here? Directrix equation is given. So this is the parabola, directrix is given 3x minus 4y plus 27 is 0. Directrix equation is given. And next one is, this is latus rectum equation also given. Okay. So this equation 3x minus 4y plus 2 is 0. This equation also given. Then the question is, what is length of latus rectum? Okay. So how to find length of latus rectum? If it is LL dash, now the question is, what is LL dash length value? Okay. So this is the question. Then again, just to make use of here standard form. What is the standard form? You know, the middle point is nothing but here focus. And we observed already from focus the distance onto the directrix is exactly half of length of latus rectum. Okay, if this is suppose m, then our z, if you take sz is nothing but, what is sz value, students? Sz is nothing but exactly half of length of latus rectum. When lengths are concerned, however the parabola, oblique or normal, that is axis parallel, horizontal parabola, vertical parabola, lengthwise they are same. That means sz always it is same as half of length of latus rectum. That implies here you don't know about s here, but nothing to worry, there is no s like that. You know clearly these two lines are exactly parallel. Okay, so whatever the distance between these two parallel lines is nothing but how much here? 2a. Okay, so now we are going to find here distance between parallel lines. Again you have observed how much important the first year concept. So now you are finding distance between parallel lines. Then make sure xy coefficients they are one and the same. Okay, then what is our formula here? Sz formula, distance between the two parallel lines, mod of c1 minus c2, that is 27 minus 2 divided by under root of 3 square plus minus 4 whole square. What is the formula? Mod of c1 minus c2 divided by root of a square plus b square. Therefore this is nothing but how much? 25 divided by 5. So you got 5 units. So this value you got how much now? 5 units. Then what about length of latus rectum? It is 2 times of this value. So length of latus rectum is nothing but here 2 times sz, and 2 times sz means the value is nothing but here 2 into 5, that is 10 units. Okay, so this is our length of latus rectum. Now let's observe this problem, students. If the parabolas, 2 parabolas given, they said the 2 parabolas are equal. Okay, and we know earlier also when 2 parabolas are equal implies they are having same length of latus rectum. Now here the latus rectum is mod lambda, and here given lambda positive implies it is positive value. And next here what about for this parabola, the latus rectum? Okay, so here the requirement is what they are asking, when 2 parabolas are equal. When 2 parabolas are equal, then what is the value of lambda? When lambda is positive. So whenever they asked here, we know the concept is nothing but both the parabolas should have same latus rectum. So here we understood that point. So here it is nothing but lambda, and here we have to obtain latus rectum. So the question is indirectly what is the length of latus rectum of the second parabola. Okay, now let us observe, students. Let us write the second equation in standard form, that is seems to be distance formula, and here perpendicular distance, that means we have to use there the denominator value. So now I am taking the second equation, x minus 3 whole square plus y plus 2 whole square. Okay, and now this value is nothing but 3x minus 4y and minus 2. The denominator for perpendicular distance we require how much? 5. Okay, we require under root of 3 square plus 4 square, that is root of 25. 5 we require. Now this is whole square is there, that means this value is nothing but how much? 25. So whole square if I write. Understood? That means clearly you got, if I take square root here, mod here, it is nothing but SP equal to PM type. But even then our interest is only length of latus rectum. So just have a glance whether the second equation, what is here focus and what about their directrix. Okay, so these adjustment just we want to know whether it is exactly a parabola or not. For that purpose we have showed. Now what is the focus here? The focus is 3 comma minus 2. And what about equation of directrix? That is nothing but 3x minus 4y minus 2 equal to 0. Now how to find length of latus rectum? So all of you know, till now we have done some problems. length of lattice rectum. Once here focus is known and directrix equation is known, then you can find perpendicular distance from focus onto directrix, that is nothing but 2a. Okay, so that is half of lattice rectum. Therefore length of lattice rectum is nothing but here half of perpendicular distance from focus onto directrix. So what is that value here? That means this value we are finding, it is nothing but sz. Okay, so first I am finding perpendicular distance from focus yes onto directrix. Now this value is equal to, what about here, 3 into 3, it is 9, and now plus 8 and next minus 2 divided by 5. So that is 15 by 5, that implies it is 3. So this is the value you got, 2a. Okay, so this value is nothing but here 2a, and now the requirement is 4a. So what is here length of lattice rectum, students? It is nothing but 6. That implies lambda equal to clearly how much here? 6. So two parabolas, whenever they are equal, their lengths of lattice rectum must be same, and here that is lambda, and here you got it is 6, hence the lambda value is nothing but here 6. Okay, so this is the answer. And next one, observe here the second problem. How is axis of parabola given? So read the problem, students, carefully. A parabola is having axis along the line y equal to x. Now students, you have to observe one important point, that is, in any problem the line equation given as y equal to x, it has lot of qualities. One is nothing but it is one of the angular bisector of coordinate axis. The other one is here on this line, one advantage, abscissa equal to ordinate. Okay, so that is the important thing you have to observe. Whenever the line is given, they are making our problem a little bit easy. Okay, so axis of parabola is along the line y equal to x, and next distance of its vertex from origin is root 2. Okay, and next that of its focus from same point origin, it is 2 root 2. Then they are asking, if vertex focus both lie in first quadrant, find the equation of parabola. Okay, so now what is the data given? Focus is given, the axis is given along the line y equal to x, and we know here origin is on the same line, both abscissa same as ordinate. Suppose this is our origin. Okay, and now from origin vertex is exactly at how many units? Root 2 units. Okay, just we are taking the advantage of the line y equal to x, and hence directly I am taking the point as here vertex as 1, 1. How I got this result directly? Because OA is nothing but how much here? Root 2. Moreover, this point A must be on the line y equal to x, whose abscissa same as ordinate. That's why this point you got here 1, 1. Hence here students, the line is OA, and this distance they said it is root 2. And immediately the other point, that is focus, is given how much here? 2 root 2. That means one more 1 you have to add, that means 2, 2. So you got nicely here the vertex value, the focus value. And we know, once you know about the focus, then immediately you can find here equation of directrix to obtain the equation of parabola. Now clearly students observe how are SA and origin. Understand, this distance total it is given as 2 root 2, and that implies this is also here root 2. That means here exactly A is how it is middle point of S and O. Implies this O is exactly our point of intersection from focus onto the directrix. Okay, now axis, how it is actually? Axis is y equal to x. That means x minus y equal to 0. Then what about directrix? Exactly perpendicular to it. That means it is passing through this point as well as perpendicular. So if it is x equal to y, you know this is x equal to minus y passing through origin. So you got directly the directrix equation, and next the focus value. Thereby we can apply SP equal to PM. Therefore what is our formula now? this is equal to under root of x minus 2 whole square plus y minus 2 whole square and equal to Pm. Pm means what is the value here? Mod of x plus y divided by root 2. Now if you do cross multiplication, easily you can obtain here the equation of parabola. Now students, observe clearly, they said here first quadrant. Same problem they might have given here third quadrant. If it is given third quadrant, then you have to take all values just this side. That means this is minus 1 comma minus 1, right? The point you have to take now minus 1 comma 1, that is exactly the other side such that the value, or they may give here not this one, y equal to x they are giving, okay? So y equal to x means minus 1 and focus could be minus 2 comma minus 2. So you must observe here, this is very careful, as they said here first quadrant, and therefore we got the parabola like this. Now same problem, if it is given as third quadrant, then our parabola will be this side, okay? This is minus 1 and the focus is here minus 2 comma minus 2. So these values you have to observe very carefully. Suppose in the same problem, instead of the line y equal to x, distance concept is given, but instead of line y equal to x, if it is given as some 3x minus 4y plus 1 equal to 0, okay? And they said here some point is there, vertex is at a distance of root 2 units and focus is at a distance of 2 root 2 units. Then what concept we have to apply? So this is the axis of the parabola, and which is here 3x minus 4y plus 1 is 0, and this is the point, suppose any value which is satisfying the relation, that is 1 comma 1, suppose I am taking, if I substitute x is 1 and this equation is satisfying. So they will give in the data from a point 1 comma 1. From a point 1 comma 1, the vertex is at a distance of 5 units. And next focus is again at a distance of suppose some other value. Then how to obtain coordinates? Then in that method you have to make use of our parametric coordinates, that is x1 plus or minus r into cos theta, y1 plus or minus r sin theta, where slope is nothing but how much here? 3 divided by 4. Then sin theta is here 3 by 5 and cos theta equal to how much here? 4 by 5. Okay, using this you can find here coordinates of A. x1, y1 is given point and this distance is r here. Then we observe x1 plus or minus r cos theta, y1 plus or minus r sin theta. Then one set you find this side and exactly another set you find the other side. Okay, again in this way if you observe in what quadrant or xy coordinates, however they ask, we write the answer in that way. So these are very important models, students. Just only thing is you have to remember the standard form, that means a diagram. Once you clearly remember where is the focus, where is the directrix, where is the vertex, etc. All these points clearly if you know, then however data given, we have observed many problems, however data is given, you can just to make use of simply the concept and thereby the answers are very simple way you can obtain, right?